Hey guys, welcome back to this another tutorial in the series of Core to Advanced Java for Automation Engineers. So this is my channel Progress Date with AJ. Here I am uploading all the videos for this Java playlist in which I'm trying to cover every aspect of Java from scratch to advanced. So uh, the engineers who is trying to move from manual testing to automation testing, this series is going to help them a lot to understand each and every concept and fetch or crack the interviews for SDT1, SDT2, SDT3 levels. Cool. Let's begin. So in the last tutorial, we have created our first project. We installed JDK, we installed IDEs like IntelliJ, Eclipse Studio, VS Code Studio, right? So in this tutorial, we are trying to understand more about Java. What are different features we have? For that, I'll quickly create one text file, and here I'll put features of Java. Right? First thing first, Java is simple language. What do we mean by simple? So Java is very easy to learn. Syntax are much cleaner, much easy to understand, right? Complex things like pointers, operator overloading are avoided in Java. Those might be confusing things of C, C++, but those are handled by different means in Java. So it is very easy to understand. Next point is object oriented. So what is mean of object oriented? So this Java as a whole is organized in objects. So objects is a collection, you can say, of data. Data is your attribute, and it is also consist of methods or functions. So that defines our behavior, right? So as far as definition is concerned, objects are just an instance of classes which consist of data and functions and methods, right? So our Java is object oriented programming language. Next thing, it is robust. So why Java is called as a robust language? Because it supports compile time error checking, runtime error checking. Also, it supports garbage collection and exception handlings. That's why Java is called as a robust language. Next one is multi-threaded. What is meaning of multi-threaded? Okay. So multi-threading in Java allows us to concurrently execute or parallelly execute different parts of our program, which is also called as a thread. So what is threads? Threads is nothing but a sub-process of our program. And Java allows us to run those threads parallelly, right? So it improves the performance, it consumes the less memory, it consumes the less CPU, and multi-threading allows us to execute the program parallelly, right? Next thing is architectural neutral, which also called as a platform independent. Okay, so what do you mean by platform independent? What do you mean by platform? Platform is nothing but the machine. Like currently I'm on Windows machine. If you are on Mac, Mac is your platform, right? Ubuntu is also another OS, right? So our Java is independent of any of the platform. It can run on any platform, right? Why it is so? Because Java execution consists of two processes. One is compilation and other one is interpretation. In compilation process, whatever we write as a program, it will get converted into a byte code. Byte codes are actually a machine independent or system independent. So it does not require to know which platform, whether it is Windows or Mac. It doesn't matter. Any machine it is, the byte codes can execute on that particular machine, right? So platform independent, why Java is allowing us to call it as a platform independent? because program is converted into bytecode can be understood by any machine. That's why it is a platform independent. In short, once the Java code is written, you can run it in anywhere. You can run it on any machine, right? As simple as that. Next is interpreted and high performance. Okay. So unlike C, C++, Java is not guaranteeing any high performance, but because Java is a compiled language. Java is an interpreted language, and C and C++ are compiled languages. So they are already compiled. But here in Java, we had to compile our program first, then we have to convert that, or we have to interpret that bytecode, right? So it involves two steps here. So of course, it will not guarantee the performance as good as C++, but here the performance is improved by one more subunit called as a just-in-time compiler. So just-in-time compiler, what it does is most commonly functions, it already compiles and keep it in memory. So wherever it is being commonly used, multiple times used, so it just call that compiled code. It doesn't perform the compilation every time. The commonly used segments are pre-computed, pre-compiled, and stored into the memories. So that is the purpose of just-in-time compiler. Okay, so that's how it tries to improve the performance of Java systems. Next is distributed. So what do you mean by distributed? So you can invoke the methods from one machine to another machine. A common example I would say remote machine invocation, RMI. So what happens in remote machine invocation? Objects from one JVM can pull objects from other JVM on the same machine or other machine. That is the purpose of RMI, right? So some more features I can list here, like it is dynamic in nature, it is more secure language, right? There are a lot of features to list here, but these are mostly being used in interviews as well. So just keep a note of those 7 features, and the understanding around those features are also important. Now coming to one more thing here. So far we talked about JDK, we talked about JRE and JVM. Let us try to understand the difference between them. JDK is Java Development Kit, JRE is Java Runtime Environment, and JVM is Java Virtual Machines. Okay, quickly I can show you this subsetting part. JDK versus JRE versus JVM. I'll just quickly open any publicly available. Okay, this one gives good idea. Okay, JDK, of course, this JVM is subset of JRE. JRE is a subset of JDK. So when we talk about JDK, it also assumes it consists of JRE and JVM. Okay, JVM is responsible for performing interpretation, whereas JRE is making compilation process by using this javac, jheap, and jconsole, right? Quickly I can show you the last time we installed JDK, right? So here I can put Java version. You can see 3 lines printed here. One is Java 21.0.8 along with some date 2025 LTS. LTS stands for long-term support. This indicates our JDK version. Okay, it is the release date is this, and LTS. So if you have installed this JDK, just try to ensure it is LTS. LTS means long-term support. It is released on this date because see, Java is getting released, newer versions are released every 6 months. So there are limitations that they can provide a support for this current version, or let's say 21.0.8. So when they say it is LTS, they are bound to provide a support for this particular version for at least 5 to 6 years. So make sure you are on LTS. Second line, if you notice here, it is a runtime environment. That means our JRE version. Okay. And if you notice the third line, it is a 64-bit server VM. That means it is our Java virtual machine, JVM. This is our version, and it is also a LTS, right? So let us try to understand a bit in more detail. I'll just quickly open the paint. So the program that we write, we may store it with some name, right? Let's say our program, or let's say my file dot Java. Java is the extension to store the Java program. This is the file extension for storing the Java program. Okay. I'll quickly draw the arrow. This Java my file dot Java, whatever program we write inside that will get converted into a bytecode. So if I can quickly show you the bytecode example also. So if you see here, these are our bytecodes. These are our bytecodes. Whatever we write here, syntax, right? Those are getting converted into a bytecode, right? So our Java program file also getting converted into a bytecode. But who is responsible for doing this conversion? The process is well known. It is called as a compilation. But who does this compilation? Compilation is done by Java C, right? So Java C is responsible for converting myfile.java into a bytecode. The process is known as compilation. Further, this bytecode is getting converted into a machine code. Right? Machine code. So this process is known as interpretation. And who does this interpretation? Our JVM is responsible for doing this interpretation, right? I can quickly demo these two processes, compilation and interpretation as well. But high level, our file gets converted into bytecode, bytecode converted into machine code. Once it is converted into machine code, it gets executed, right? So instead, okay, to show those two processes, I will not use the IDE. Instead, I will quickly create one file here. I'll name it as pro.stet. Later we will change the extension. For now, let's keep it as txt file so that I can edit it. And here I will write some simple program. So we'll define the class as pro.stet. Let's not worry about what is class, what is this public and something like that, right? We will be dealing with those only. We will discuss a lot on those. But for now, let's try to understand. This is a simple Java program. Public static void main. I'm writing a main function here. So it will accept string args. And here we can write our program. So in program, I will simply write some print statement system.out.println. Okay. Into bracket, I'll put some pro.stet with aj. Cool. I'll just put a semicolon to complete that statement. Close the parenthesis as well and save it. Okay. That's it. Now we know that our file is stored here. So what I will do, I will just change this extension of this file to Java. So this will be treated as our Java program. Done. Cool. Now you can see the extension got changed to Java. Here in the address bar, I'll simply do one thing. I'll type here cmd to open a new command line into same folder. You can see the path ashish desktop.core java. So here what I will do, I will perform this first step. First step was compilation, which is done by Java C. Okay. Okay. So here what I will put Java C. I'll tell Java C to execute my program file. So to execute my program file, what I want to do is to give the name. So I'll simply press tab. It will capture the file name as it is. Now what will happen? It will perform our first step of compilation. So you will find one more file is getting generated here once I hit this. Okay. Are we facing any error? Okay, let me try to reopen this. CMD. Here I will put Java C, Java compiler, and file name proestate.java. So if I execute this, you will see our bytecode file. This is a file with a bytecodes. Okay, if you open this, you will not understand anything because it is a bytecode, right? But it can be executed on any machine since it is a platform independent, right? Next step is interpretation, right? So I will run it with JVM. So this time I have to run this class. So class is created. This class is our bytecode. This class I will run this time. Okay. So I will simply put Java proestate.class. Now this time the class extension is not needed. You can simply give a file name and execute. You can see proestate with AJ is getting printed because this is what we have written in the Java program file, right? So that's it for today. Stay tuned for more videos on the same line, core to advanced Java for automation engineers. We will be structuring those tutorials into 3 parts. In every tutorial, we will try to cover some theory, then a lot of program practice, and we will conclude the videos with interview tips, interview questions, so that the candidates who are pursuing or trying to change their profession from manual testing to automation testing, let it be SDT 1, 2, or 3, SDT 3. So we will begin with very basics, and we will try to reach advanced levels, system level designs with Java for automation frameworks. So stay tuned, guys. Bye bye.